Hey, this is OXDF, and today we're doing Advent of Code Day 23, a long walk. Um, we are going to get a grid. It's the year of the grid. And the grid is going to have spaces we can't walk, forests, the pound sign, paths, which is the dot, and then arrows, the four different direction arrows. And those are slopes that we can only go one way. So if we reach this slope here, we can go down, but we can't go back up. So that's what they are. We prevents loops, I guess. And our challenge is to get from the entry point, which is the only path on the top row, to the exit, which is the only path on the bottom row, uh, in the longest way possible. That's it. This is actually an incredibly straightforward challenge. They want to know the length of the longest path. Now, full disclosure, I solved this, and it was kind of a meandering video with a lot of mistakes. But I was looking over again. I looked down when I solved part one to say like, hey, did I? How am I doing on time? I never hit record again. Second time this year. So we're gonna do it again. I've just removed it all, so I'll probably make some of the same mistakes, and I'll try to point out if I don't make the mistakes. I'll try to point them out anyway. So let's run over here. I've got my Genday script for J23. There's a link to this script in my repo, or in the description to the repo, which has this script as well as all the answers. It pulls my input and creates a stub for me. It does not create the example, so I'm going to put that in myself. Before we get coding, let's look at the input.txt. Much like the example, we'll look at the example because it's a little easier. There's a lot of long stretches where you have no decisions whatsoever to make, right? So you start here, the only place you can go, you're not allowed to backtrack. So the only place you can go is all the way till you get to right here. Similarly on the input, we got to go here, around, up, through, up, down, up, all the way to here before we have a choice about which way to go. And so as far as I know, there's no efficient way to get longest path. To get shortest path, right, we can do like a breadth first search where we search all the spaces one step away, then all the 2 steps away, then all the 3 steps away. And so if the answer is 7 steps, we check the 7 steps, we're going to find the answer, and we never check 8 steps away on any path. For longest path, we're just going to have to check every possible path. And so what we're going to do to gain efficiency is we're not going to try to check every possible step, but we're going to take a map and we're going to get all these points where you actually have choices. And we're going to just say the distance from here to here is, I'll make up a distance 50. So we're just going to know that's 50. We're not going to try to check every point along the way. So let's go ahead and do that. We're going to call this grid. We are going to remove new lines because that always bites me. It actually bit me in the last video. Cost me a little bit of time. And then because I know I'm going to come up with it later, I'm going to want this. I'm going to go ahead and define height equals len grid and width equals len grid 0. All right, so we want the starting point, which is going to be equal to 0, because we know we're on the 0th row, and grid 0.index of dot. And end is going to be similar. It's going to be len grid -1, bottom row, and then grid -1 dot index of dot. So we have our start and end points. We can check those real quick. Start, end, Python day 23 example. Looks reasonable. All right, so next thing we're gonna do is gonna find our points of decision. I'm gonna call them junctions. Junctions, so we're gonna start off with an empty list of junctions. And to find the junctions, we're going to, we're not gonna start with an empty. Let's add start and end, because those actually won't be found by our algorithm, but we want to add. So now we can say for r comma row in enumerate row, not row, grid. For c comma ch in enumerate row. So we're going to look for places where we could step that have choices. So that's going to be if ch is equal to a pound, we're going to continue because that's clearly not a point. Now the way we're going to do is we're going to count our neighbors, and if there are more than 2, because if there's 2, that's kind of like where you came from, where you're going. But if there's more than 2 places on the path that you could step, that's when we care. So we'll say num neighbors equals 0 for dr dc in, and it's our common thing here, 0 comma 1, 0 comma -1, 1 comma 0, and -1 comma 0. So for each step we could make, we'll say nr and c equals r plus dr c plus dc. So we got our next step. If we're inbounds, so we're going to say 0 is less than or equal to nr is less than height, and 0 is less than or equal to next c is less than width, and grid nr and c is not equal to pound. So if all of those things are true, it's a neighbor. We'll do num neighbors plus equals 1. I mean, a neighbor I'm defining as a thing you could step. And then we can say if num neighbors is greater than 2, junctions dot append r comma c. So if we save this, let's come down here and we will make this to be junctions, and we'll run this again. And we get 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's see, 3, 11, 5, 3, 3, 11. That was about right. There should be 2 more that start with 3. Oh no, they're not. No, never mind. That's not true. 3, 11. Oh wait, 3 is on the 4th row. Yeah, okay. 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, and that's a point. Sweet. Okay, that looks good. I'm happy with our junction. So now we're going to create a map, and that map is going to tell us from each junction the distance to any other junction it can reach. And we have to go both directions because of these directional things. Like, so you can go from this first point down to this one, but you can't go back. So let's see, we'll call this jmap is equal to there. And we're going to say for jr, jc in junctions. We're going to get a junction point. We're going to say jmap of r comma jr comma jc is equal to another dictionary, because we're going to want to store now the keys are going to be the other point we can go to, and then the value is going to be the distance. And we're going to do a queue. We're just going to do a breadth first search. From each point, we'll fill out and find things. So we're going to say we're going to need a deck. Collections, import deck. So we're going to say q equals dequeueue, and we're going to start at jr, jc, and we need a distance of 0. That'll be our state. Scene will equal set. We'll say while q rcs is equal to q dot top left. So now if r comma c in scene, so it's already been there, we can continue. Otherwise, we're going to scene dot add r comma c, and now we want to check. We're going to say, well, if we've reached a junction point, so if r comma c in junctions, then jmap of jr jc of r comma c is equal to s. And so basically we've now got we can now, for any junction, we'll say, if I look up the junction, this point is this far away. And once we've reached that junction, we don't want to continue. We're not going to continue because we don't want to go to the next junction. We just want to stop. We've reached a junction. Otherwise, we need to start thinking about we didn't reach a junction, what next step can we take? And this is where it matters what space we're on. So we'll say match grid RC. Case, if we're going up, then next step equals -1, 0. Case of, if we're going down, next steps equals, and I'm making these lists because we're going to loop over them because there might be more than one. So like that, if we're going down, case of sideways, next steps equals, this will be, we're going to the right, so we'll be 0, 1, and we'll case of that way, next steps equals 0, -1. We need that as a tuple. And then we have the case of dot, and this is why we're making these lists. Next steps equals, I'm just going to grab u. If we're on a dot, we can go any direction. I'm going to do a case underscore third false. We should not have anything else that we've reached. We should not be stepping somewhere else to reach another point. So now we can say for dr, dc, and next step, oops, that's not part of the match case. There we go. Nr and c equals dr, r plus dr, C plus DC. Now we get our next spot. We want to say if 0 is less than or equal to NR is less than height. So if we're in place, if we're in a valid spot, and 0 is less than or equal to NC is less than width, and grid NR NC is not equal to a pound sign, then we can step there. So Q dot append NR NC, and then the steps is going to be steps plus 1. And so effectively what we're going to do here is we're from each junction point, we're going to start a flood or a breadth first search or whatever I want to do it. And we're going to do it until anytime we reach another junction, we're going to stop continuing. And if we don't reach another junction, if we don't, we're going to go to all the next steps we can go to until we find all the junctions that can be reached directly from this junction. And we're going to put that in our map. So we can run this. And I don't think with the example this is going to be too big. It's not. So from the first one, let's see. From the first one, we can only go to its. Okay, that's not. We need to do another check here for RC. If RC in junction, RC in scene, yeah, RC in junctions, and let's see, if RC not equal to JR JC, and there we go. Try that. You don't want to add yourself. That looks better. So from here, from 1, 0, we can go to 5, 3, and 15 steps. From 22, 21, we can't go anywhere. And that's fine because we actually, I'm guessing we go backwards and we hit a slope. So there's nothing we can go to. That looks fine. 3, 11. We should have multiple we can go to. Yeah, looking good. Okay, so I think we're good there. Okay, now we've got our J map. So what can we do? What can we do with that? We're gonna do like another search, and this time we're just gonna, now we're gonna walk the map, right? So we'll say Q equals dec. In this case, we're gonna go from start. We're gonna track our state is gonna be our current position and every position we've come along the way. So we're gonna say dec equals like this. We start that, and then so that'll be R, C, and then the path will be this, where we do start that. So that'll give us tuple. I think that looks good. Missing a close there. Let me just make sure that looks okay. Whoops, didn't mean to close you. Python day 23. Oh shoot. CD day 23. Python day 23. Example.py. Q equals. Don't need you. That was me. That fingering. Okay. So our Q is going to be. Let's see. Let's see. Q dot pop. Yeah, okay, so RC and then the place we've been. That's what we want. Okay, I'm happy with that. So now we can say path equals, whenever we find a valid path, we're going to store it. So we're going to say while Q RC path is equal to Q dot pop. I'm going to pop instead of popping left. I don't know this actually matters, but I think it might make our state run a little bit short. I'm not confident that actually matters, but because we're having to do everything, I don't think it matters. It might add something. So if we've reached the end, we found a path. Path.append path continue. That's easy. Otherwise, we're going to loop the next points from this one. So we're going to say for next point, comma distance in jmap of r comma c dot items. So this will give us the next point and the distance to that point for each. So for each, we're going to go to our map. We're going to say, here's where we are. Give me the places I can go and how far away they are. And then we'll say if next point in path. So we've already been there. We're going to continue. I guess let's do next point not in path. Then we can do q.append And what are we appending here? We're going to append next point like that. And that I'm just expanding it here to make that to be R comma C. And then we're going to say path plus next point. And I'm doing this, instead of adding it to path, this is going to create a new object so I don't have to worry about any, it might be memory inefficient, but it's at least going to, I'm definitely not going to be like modifying the same object in ways I don't want to. And if this works, let's see. Let's look at this, see what happens when we run this. Not too bad. Len p for p in path. Oh, that's not quite right. Okay, so I don't need to do the length. Now I need a way to figure out the distance. So I need to go down all these paths, right? So what we're gonna do, this is kind of cool. This is actually kind of cool. So we're gonna say, we are going to zip path and path from 1 on. And what that's going to do effectively is it's going to give me the pairs, these two, then these two, then give me the first two, then this next two, and that way I can sort of get the start and destination all the way to the end. And because the endpoint's here, the last one will be these two. And so I can say P1, P2 in, like that. P1, P1. Okay, so like that, that's a valid list. Now what I want to do is get the distance from this one to this one, right? So I'm going to do jmap p1, p2, and that's going to give me the length that I need for any given path. And then I can say sum of this. And so that is going to give me the length of a path. So we could do this. We'll do this. We'll say longest equals 0 for path in path. Longest equals max. Longest sum of paths. Part 1. I guess really I can call this part 1. Call this part 1, and I can get rid of you. I can run you. Whoa! And I can call you part 1. And I can run it. I get 94, which I believe is the answer. And because I already solved it, we'll just see if I can get that. So 94 is there, and we can see if I can get 2166 with the input. 2166, we did it. All right, part 2. Now basically what they're saying is, never mind, there's no problem climbing slopes, so basically treat slopes as if they're paths. So I think this is actually quite easy. We just need to, so if we wanted to just solve it, and what we literally could do, come here, take this, paste, overwrite this match effectively. And if we run this with example, we get 154. If we run this with example, where's the example? 154. Now, is this fast enough? And the answer is kind of. I'm not sure if I'm going to try to talk to you the whole time this runs, but it runs in like 30 seconds or so. I should have timed it. I will do a timed one. I might not make you watch for the whole time, but it's one of those things where like in real lifetime it's not very long, but when you're sitting here waiting for it to run, it feels like an eternity. So I'm not sure how much more I can ramble. If it doesn't finish pretty soon, I will pause the video. But I think I can't think of a way to make this more efficient than what we just did. And there we go. We got an answer. So let's see if it's the right answer before we get too happy. Awesome. So what we could do, what I should, it says part 1. That drives me crazy. Let's see. What we would need to do basically is turn this into a function and call it twice. Once, I mean, we could literally copy paste all this. That'd be awful. Let's do it real quick here. We'll do so we will come up here and we will say def make jmap. I'm not even sure what we need to pass in, but we're going to grab u cut paste. We need to tab u in. I think this is, part 2 equals false. And we can say if part 2, like that. So now we come down here and we say jmap 1 equals make jmap that. Make you. And then I guess we're gonna make this into a function too. Q's appends. Is this actually? Yeah, it does matter. So we're gonna say I'm gonna undo calling it make jmap. We're just gonna call the. We're gonna make this all one giant function. Part 1 equals solve. Grab u. Have u in here. So basically, we're just gonna do this whole thing. We call this solve. If part 2 there. There we go. We even need to grab this, put u here. So I'm going to say we will call this longest. We'll say for path and path, we will call u longest, and we will return longest. And now we put all of that into a function. So we just come down here and we're going to say solve and solve true. Let's see how that works. Woo! Didn't like that. Let's see. Maximum recursion depth exceeded. Where would I recurse? I don't think I did any recursion. Oh, we should longest equals 0. 94 and 154. Input here. Oh, wait, hold on. If I'm going to run this, I might as well do time. So we saw part 1 was basically instant. And part 2 looks like we got some time. So anyway, while this runs, I'm just going to summarize. Kind of a neat problem. Longest path is always challenging because you really just have to brute force. But by breaking the problem down into the pieces that matter, that's where we got some efficiency out of this. So that is where we get our answer. Part 2, it's not super satisfying that I have to like wait this long, but 30 seconds. 30 seconds is not too bad. So I'm gonna call it here. If you've made it this far, you probably watch me fairly regularly, so I appreciate that. I can't promise I'm gonna be able to get this video out tomorrow for day 24. I'm gonna do my best. I'm gonna be traveling. I'm gonna be not at my house. I will have my laptop. I might not have a camera. But I'm not even sure if I'm gonna have time to do it. So I will do it eventually. It just might not be tomorrow. So happy holidays to those of you celebrating, and thanks for hanging out with me. And I'll talk to you soon. Bye.